No. Okay. Good afternoon, everybody. Thank you for the okay. Thank you for the introduction. I'll talk about this mission, which is POEMMA-Balloon with radio, which will be a third generation uh, instrument on a balloon, which will be flown hopefully in 2027. This is a precursor for a future space mission for multi-messenger astrophysics. The idea is to look from the edge of space down at the Earth atmosphere and using the Earth atmosphere as a giant particle detector. The three main objectives of this project are: the first one is related to the ultra energy cosmic rays. We want to make the first observation of ultra energy cosmic rays shower development from above. The second one is to measure with a significant number of high altitude horizontal air shower, and this will be done via optical and radio emission. The third objective is to follow up for transient neutrino events from multi-messenger events. Of course, there are also other objectives. The main technological objective is to raise the technological readiness level for a future space mission, and also do the first observation of Cherenkov and radio emission from high energy cosmic rays. This project is in the framework of the GEMUSO collaboration effort to study fluorescence emission from space. I said this is a third generation instrument because the first one was the USO balloon and then USO SPB1, which was flown first on a balloon from CNES and then from NASA. Then we had the USO SPB2, which was an upgraded instrument, which also had beside the fluorescence telescope, also a Cherenkov telescope. PBR is a further step toward POEMMA, which would be a space mission to study both Cherenkov and fluorescence emission. USO SPB2 was launched last year from Wanaka in New Zealand. As I mentioned, it had two 1 meter diameter telescopes. One was to study fluorescence and was pointing down, while the Cherenkov telescope pointed at the limb to study the neutrino background and to follow up events. We also had the infrared camera and several other ancillary devices. Unfortunately, the flight was terminated after only 2 nights, so we didn't have really time to collect any data. We were able to acquire some data and download it, but unfortunately for the fluorescence, we didn't have any event, which is compatible with the rate that we expected. We have some candidates for the Cherenkov observation, but still not confirmed. This one was quite unlucky. Let's see what we are aiming toward. POEMMA stands for a Probe of Extreme Multi-Messenger Astrophysics. This is a NASA conceptual design for an astrophysics probe class mission 1. This design is for 2 satellites flying in formation on low Earth orbit. And both satellites would have a large field of view and 4 meters Schmidt optics with an hybrid focal surface. And the idea of having an hybrid focal surface is to have to study the fluorescence with multi-anodic photomultipliers with 1 microsecond sampling, and to study the Cherenkov emission with the silicon photomultipliers and a faster sampling of around 10 nanoseconds. This instrument would work in 2 observation mode: stereo, which is the one in which both point down, and this is one is optimized for the ultra energy cosmic rays, and both looking at limb, optimized for the detection of astrophysical neutrino. The PBR mission is planned to fly on a superpressure balloon. The superpressure balloon work at a floating altitude of about 33 kilometers. And this launching from New Zealand means that we are at mid-latitude, and we can fly, we can have dark period for observation, but also light during the day to charge up our batteries. And the idea is to aim for a 100-day flight, which would give us around 500 hours of operation. I mentioned that USOS PB2 was terminated after only 2 days, so you can really see the path here. But in the same year, another balloon was launched and reached 40 days of duration. So we are, I mean, we have all our fingers crossed for a long launch. The scientific payload can weight up to 1.5 tons. And this is how the payload looks like. You can see that the scientific payload is getting more complex. This time we will have a slightly bigger telescope, which will have an hybrid focal surface. So we are going in the POEMMA direction. We will also have a low frequency radio instrument and several small detectors for X-ray, gamma, and particles. Of course, the instrument will be also equipped with an infrared camera, which allow us to measure the cloud coverage, which is important to estimate the field of view of the fluorescence camera. The telescope would can be moved around with the NASA rotator, and is it's important if we want to follow up for multi-messenger event, but can also tilt looking both down at nadir and then above the horizon. And this will allow us to observe different kind of phenomena. Of course, being a long duration balloon, it will be equipped with telemetry, both to send commands and to download data. For users PB2, we also flew Starlink, and it was actually the main reason why we were able to download our data, because it's way faster than the NASA telemetry system. And of course, solar power system. This is the sketch of our hybrid telescope. We will have a Schmidt optics. Besides the mirrors, we'll have also an aspheric corrector plate to correct for chromatic aberration. And the optic is also composed by a small bifocal lens, which allow us to have bifocal for the Cherenkov part of the focal surface in order to have some background reduction. You can see that this follows the POEMMA idea. So we are using multi-anodic photomultipliers for the fluorescence camera, and we have around 9,000 pixels. So we have 4 photo detection modules, which is one more than we flew with the USOS PB2. The integration time is around 1 microsecond, and with the fluorescence, we are using a BG3 filter in order to reduce the incoming light only to UV light to reduce the background. The Cherenkov camera is composed by 4 rows of silicon photomultipliers matrices for a total amount of about 2000 pixels. As I mentioned, we have bifocal for background reduction, and this telescope can see also visible light. The integration time is way faster than the one that studies fluorescence, so it's around 10 nanoseconds. The main objective of the fluorescence camera is to observe ultra energy cosmic rays from above, but by tilting the telescope, we can also achieve some other objectives. We can observe high altitude horizontal air shower, measure the evolution of the air globe by tilting the telescope, and by tilting up, we can also observe star, and this is useful for calibration of the instrument. Compared to USPB2, we have an increased field of view given the fact that we have one more PDM, but also that we have a larger mirror, and this means that we can collect more light. And this should allow us also to reduce the threshold. The expected threshold is around 1 His electron volt with a peak sensitivity of around 4 His electron volt. For the Cherenkov camera, we have 2 different modes. The first one is to looking above the limb. And here we have a guaranteed signal of horizontal showers. We have performed an extensive simulation study, and we expect around 60 events per hour with an energy threshold of 400 TeV and a maximum sensitivity around 2 PeV. And you can see that the energy of the shower that we are able to catch changes with the angle. If we look below the limb, we have very limited sensitivity to the diffuse neutrino flux, but we should be able to see transient by pointing. So we call this target of opportunity because we can follow up galactic supernova, GRB, black hole mergers, but also study steady sources such as the TA hotspot. We are getting ambitious, so we are also flying a radio instrument. This one is modeled on the POEMMA low frequency instrument design. And the frequency range goes from 50 to 500 megahertz. We have a field of view which is overlapping with the Cherenkov camera. And the main idea here is to use the radio 24 hours, 24/7, let's say, but to use the radio in combination with the Cherenkov camera during the night. So we will have both optical and radio signal. The expected threshold for the radio is higher, but we are working on machine learning techniques to lower the threshold. Finally, our small X, gamma, and charged particle detectors. The main idea is to do study in combination with both the Cherenkov and the fluorescence camera, but also we realize that we have the opportunity to be within the shower development, and so this can be useful to study what is happening inside the shower. Here you can see our schedule. The proposal has been accepted and funded. The design is well underway, and we have started the procurement of the first and the prototyping of the instrument. We have submitted our flight application for 2017, and to be honest, the schedule is tight because we also want to squeeze in some field tests, which will allow us to to calibrate our detector response and also to have some cosmic rays data. And this has been done for USPB2 from the telescope array site in Utah, and we plan to do the same this time. To summarize, POEMMA-Balloon with radio is the successor of USPB2 and an advanced precursor for future space mission like POEMMA. And our preparation has started for a flight from Wanaka in New Zealand in 2027.